Welcome everyone to our session, How Physical AI is Transforming Industry. In this session, we are going to explore where digital intelligence transforms the physical world through manufacturing, automation, robotics, and more. My name is Maria Rueter, and I'm a Global Partner Management Lead for Siemens, focusing on industrial software, edge-to-cloud integration, and industrial AI. Let me introduce our speakers. Sri Elaprolu is the Director of Generative AI Innovation Center at AWS. Sri is a technology leader of more than 25 years for artificial intelligence and machine learning. Sri leads a global team of engineers and scientists who apply industrial AI to solve complex challenges for enterprises and public sector. Welcome, Sri.
Thank you.
Joining Sri is Dr. Horst Kayser. Horst is the visionary leader who drives the digital transformation in manufacturing by integrating informational technologies with operational technologies. And his focus is on artificial intelligence combined with the physical machines to drive sustainable, resilient industrial operations. Welcome, Horst, to the session.
Thanks for having us.
Together, we will reveal what physical AI initiatives you are doing and how it's developing today. We're all witnessing the big growth of the physical AI. According to the latest report of SNS Insider, the market is predicted to be 5 billion right now and growing up to 50 billion by 2033. It's 33% over a year growth. It's enormous. But let's start with the basics. What is physical AI and why it's actually happening right now? Sri.
Sure, I can start. So we've seen over the last 2-3 years the growth and impact of generative AI, more broadly artificial intelligence. And what we're seeing with the physical AI is now, rather than just limiting it to the digital world, we're actually able to take AI into the real world or the physical world. So when we think about physical AI, it's the ability for us to take the artificial intelligence capability, fuse that with the real world, the physical objects, and get functionality going in that way. So it's in a very exciting space. I would probably double-click into 4 areas of physical AI that's making this possible at this point in time. The first is the technology improvements themselves. We're seeing technologies such as sensors and fusion of those sensors between vision, audio, and movement all happening, and it's progressing at a rapid pace. So that's one factor that's driving this innovation to move at a rapid scale. Second is the amount of data that you're able to gather and generate, in fact, in order to tune these models that actually power these physical objects. So that's the second area. The third area is the models themselves. So something that's different between generative AI, where we dealt with large language models or LLMs, was where we were dealing mostly with language. With the physical AI, we need to actually deal with objects. So real perception, depth, all of those sorts of objects, areas. And so for that, vision language action models, or VLA, is an area that's seeing a rapid growth and improvement in the ability for those models to perform. And then the last thing is just the market readiness. We're seeing the market being much more ready and willing and accepting. And you see companies such as Amazon deployed more than 1 million robots in our fulfillment centers, driving innovation and reducing cost and reducing speed of delivery, helping customers achieve outcomes that they're looking for. So it's the right time with the right technology enablers that are driving this to happen, and we see that growth happening over the next decade or so.
Horst, what is your perspective?
Yes, absolutely. I couldn't agree more, Sri. I also think that physical AI is now the landing, if you will, of the exploding capabilities of artificial intelligence now on the real world floor. May it be the street with autonomous cars, or may it be the factory floor, leading to more and more autonomous manufacturing. So we are, in fact, seeing real-life impact and real-life actions as output of the AI models rather than only digital analytics or digital results. And so physical AI is here now because it offers these huge opportunities to push the boundaries of automating human labor. yeah, and enable us to accelerate that process to replace human labor, and not only in the repeatable fashion, the standardized worker kind of activities, but also ever more in reasoning and decision making, and really going towards autonomous action. And that has, of course, a tremendous opportunity in productivity to drive flexibility and resilience of plants. Automation has come a long way. I mean, if you remember, it actually started 2 centuries ago with mechanical automation, and then the mechanics were driven by steam, later by electricity, a fundamental technology. And now, since we went to electricity, electronics, digital control, now we're going towards AI-based control, and AI thus really proves to be a new general-purpose technology that will infiltrate all physical activities. I'm fully sure.
Yeah, technology is converging. Manufacturing also moving from rigid to intelligent systems. But let's dive a little bit deeper to understand what are the technologies really driving physical AI. What is enabling it, Sri?
Yes, so if automation is not new, I mean, we've been doing automation since 1950s in factories and in other settings. What's really changing over the last few years is the 3 particular areas. And for physical AI to function well, those 3 areas are critical. The first is ability to sense, right? So when you have for example, a machine that's able to sense, and when I say sense, it needs to have cameras for vision, it needs to have depth perception sensing, it needs to have audio sensing, it needs to have ability to move and navigate, right? That sensing capability has improved dramatically over the last few years. And we're seeing that improvement continue to double down as we move forward. So that's the first enabler. The second area is once you sense, the object has to take an action, right? So that's where you actually do something. And that something, again, if you think of a robot, being able to arm and provide an arm to a robot so that it can actually lift things, it can drop things, it can touch, feel, right? That ability to actually do actions is also rapidly improving over the last few years. And then the final piece, which is central, and I would call it the brain, is critical to operate all of this, right? So again, the difference between what we have seen in the past with automation and robotics than what we're seeing now with physical AI is the AI element, which is letting physical objects determine the course of action that they're going to take and not necessarily always pre-program exactly the way you want them to do, but rather have enough flexibility and reasoning ability, and that's where the brain comes in. That's where the models, the foundation models come in. And so that's an area where there's tremendous progress that has happened, both from a training perspective, where you're able to train these models in a much more comprehensive way, so that these models are able to guide machines to navigate things that they have not seen before, that they have not been trained on before. So that's the first thing, is ability for us to train these models in a much more comprehensive manner. The second is actual inferencing, or actually doing things in the real world. And that's where real-time inferencing matters, whether you're training a model in the cloud, deploying it to the edge, and that combination of distributed brain power is critical, and that's really an exciting area that we're seeing innovation on. And then the third area is the models themselves, right? The models are getting really comprehensive, where, again, you're bringing new techniques such as transfer learning, reinforcement learning, where even though you may have trained the object to do, or the model to do one thing in a particular area, when the object goes into a different setting, it's able to adapt. And that's where transfer learning and reinforcement learning and other techniques such as that come in. So again, by combining these innovations happening in different areas, we're actually seeing that resurgence and surge in physical AI taking shape.
Thank you, Sri. So it sounds like a magic. Yeah? Physical AI gives eyes, machines to see, brains to think, and then hands to act.
Right.
But the companies still have challenges to implement this and go from the pilot to production. So Horst, what are these challenges that companies experience?
Yeah. I think it's basically in three areas. It's the general complexity and diversity of manufacturing. Then it's the difference between brownfield and greenfield, and it's in general the necessary transformation from OT, operational technologies, to IT. Talking about complexity first. Manufacturing obviously happens in the real world with real physics, and there are so many different things. You know, you can be grinding, you can be smelting, you can be metal bending, you can be assembling, you can be welding, and there's a countless number of different manufacturing technologies that always have to be combined to make a very specific a product a reality. So to train the models on all these activities, you have to, as Sri described, you have to use these wide ranges of models that we are now being able to construct, and that's really where the impact is now happening with the tremendous amounts of data and compute we can handle nowadays. We can do these more generalized models to learn manufacturing activities in all their variety. So training and learning is the key driver, obviously, behind all of this. And for that, you need access to data. And access to data has a technical issue, because if you have very specialized processes that you only have in limited scale, then you don't also have the high scale of data that you need to train your models on it. On the other hand, it's also a little bit of political business aspect. Everybody wants to own his data and knows that data are the new gold, so to speak. What you need to do is build ecosystems, build trust, work together with people, and have a joint data pooling activities, if you will, to enable models to get a wider access to learning and training them. The other thing is that in manufacturing, of course, we have hundreds of billions of dollars or euros invested in existing manufacturing infrastructures. You can't throw them all away and start new with technically, mechanically more flexible approaches. But then on the other hand, besides these brownfield, you have new greenfield activities. And so you have to also, as a player being active in this field, you need to offer your customers possibilities to optimize the brownfield step by step in a more incremental way. And of course, you need to really be able to install state-of-the-art AI-driven flexible manufacturing in the arena where it's possible when you start from scratch. And that goes then further to the overall OT-IT transformation, as I tend to call them. And we, I think, as a company that has been working with the OT community, that sometimes are like mechanically oriented technicians that are working with their machines. And we need to be able to work with them and make them learn and understand what the computer scientists are talking about when they are talking about these AI capabilities. But then on the other hand, we have to work also with the AI experts to have the patience to take the customers with them on this journey to really leverage all these capabilities that you have when you apply AI tools to an existing OT environment.
Yeah, you mentioned Siemens is already for a long time in this space, yeah, and bridging this gap. So what are these initiatives that Siemens is already doing in the space of physical AI, and what are the new perspectives that are looking to in the future?
Yes. I mean, Siemens absolutely is around for 175 years, has been, if you will, grown with the basic technology of electricity, and then over the years with electronics, digital control. And now, of course, we are making this bridge into AI-based digital solutions. And so we as a general focus, we are developing our digital control base that's closer linked to our hardware controllers still, automation models. We want to bridge that and bring them into a more software-defined automation architecture that's then also more open and perceptible to AI tools to drive engineering process, to make it faster and more efficient, and also to optimize manufacturing while it runs. And to get there, we do that, of course, also step by step. For example, we have developed the first fully virtual PLC, where the PLC is no longer contained in its a typical PLC like a box, but is able to run in a cloud-based environment. In our customer Audi, for example, it's a private cloud on their premises, but it's a clearly cloud-based virtual PLC installation. We have gone towards engineering tools that are much more IT-like, so going beyond the traditional function block and other engineering tools that traditionally automating was used for automation purposes, now to a classical a programming language type of approach that again is open for AI-based co-pilots, where the co-pilot can then help you to really generate the code much faster and really generate 30-40% productivity boosts in the engineering of your automation solutions. So these co-pilots are an important next step. And then we have also developed an industrial edge system that allows you to integrate control and have other processes like AI-based algorithms to optimize your production run on the same platform, and also to collect data from the manufacturing process more systematically. And so that is a typical bridge, if you will, reaching from the classical OT sphere into classical IT-based landscapes now that you can then approach with typical IT tool and approaches, and which is still integrated into our landscape of totally integrated automation. And then besides these concrete products, we have certainly ongoing a number of important initiatives to continuously develop our AI capabilities and also show our customers what's possible. For example, we have an autonomous factory lab where we can always try out the latest developments. We have, as we have announced quite recently, a data alliance with a number of oftentimes small and medium-sized enterprises where we try to pool concrete operational data to, as I explained earlier, to train the models on a broader base of manufacturing processes. And of course, we are continuously widening the scope of our strategic partnerships. We have certainly one with AWS, for example, but we have also an important partnership with NVIDIA, with Microsoft, with companies like Sony or PhysicsX on different aspects of the wide area of possible AI-driven tools to drive productivity in engineering and automation. And then, of course, we have our Siemens Accelerator, which is an open digital business platform with a digital and AI-based portfolio, an ecosystem of many and increasing number of partners, and actually also a marketplace where our tools and also tools by third parties can be acquired and downloaded for rapid application in the manufacturing environment. So we are pushing really on many fronts forward, and also our CEO Roland Busch has announced just 2 months ago that in the next years we're going to invest over $1 billion investment into the development of future AI capabilities.
This is a broad range of topics, initiatives, and real products with software-defined automation that you provide to the customers and driving this physical AI closer and closer. At AWS, what are the initiatives we are driving? What are the goals?
Yeah, so as Dr. Horst has said, Siemens is doing a number of things in the physical AI space to drive innovation and take the value out of that ecosystem. What we've done at AWS recently is we announced a fellowship focused on physical AI. And the whole idea is that there's a lot of innovation yet to happen, right? while the technology is exciting, there are real-world problems that we want to solve. And to do that, we've launched a fellowship in close partnership with NVIDIA and MassRobotics. And the idea behind the fellowship is we will bring startups that have really compelling ideas to solve real-world problems into the fellowship. We enable them by providing them access to AWS cloud services, whether it's the compute, storage, AI services, and so on. We bring our expertise from a science perspective to help enable those startups to move faster. We also bring capabilities from NVIDIA, their software and hardware stack, as well as their expertise, and then open up the network from MassRobotics, both from an investment side, but also from a partnership side. All of this to jumpstart these startups to go do real-world problems, solve those problems using physical AI. And we've gone through the first cohort, which we announced in October of last year, and that has now resulted in number of startups having built real problem-solving solutions. For example, in the autonomous construction space, in healthcare space where robotics are taking certain actions, in sustainable farming. So there are a number of areas that these startups have built real-world solutions that are scaling to solve problems for enterprises across the globe. We've also announced the second cohort. Applications are actually open right now till end of this month. But the idea here is that innovation has to happen across the board. While companies such as Siemens and AWS will invest and continue to innovate, we want to bring the ecosystem together by partnering with companies like NVIDIA, bringing experts from MassRobotics, and then getting the next wave of innovators to build solutions for real-world problem solving. So we're excited. We think that we're at the very early stages of physical AI and where we can go with this. But the next few years are going to be really exciting in this space.
Thank you. It's amazing to see how we move from the concepts to real initiatives, real projects and products. What AWS and Siemens can do to democratize physical AI to the companies of all sizes. What are the key things you would like to share?
Yeah, I think as I mentioned before, I think what I think is really important that we're both promoting open access to data and build trust with our customers to share data and that they will benefit from that. So the wider we can train the models, although of course nowadays there is the possibility through simulation also work with synthetic data. But in the end, if you have real data and real customers on board and really big global enterprises as well as small and medium enterprises, the machine builders, which are such an important part of this manufacturing process, and we have very long-standing customer relationships with. So that's, I think, that's really crucial. And so when we both can also promote concepts like the Siemens Accelerator as an open digital business platform with mostly open APIs of the tools that are being offered, so to seamlessly integrate and easily deployed to applications, that will help to lower the barriers to gradual implementation. On the other hand, between our two companies, we have very concrete initiatives like our Siemens low-code engineering and programming environment to run on the Amazon Bedrock platform, where we can show how more OT-oriented solutions can benefit from IT-like infrastructures. And the same is true for the AWS IoT Sitewise Edge and the Siemens Industrial Edge that can work in an integrated fashion and thus provide a bridge for operational technologies for OT into the cloud, and also have a larger or drive the larger integration between OT and IT. And I think if we do this together, again, we are forwarding the trust with our customers to try this out and to see the benefits when they're making this jump forward.
Anything to add, Sri?
No, I fully agree with what Dr. Horst has said. One thing maybe I'll add is the combination of Siemens' expertise and the data in the decade and centuries of expertise when it comes to manufacturing processes, and combine that with the IT experience and expertise that AWS brings with the cloud technology plus AI and artificial intelligence science capabilities. That fusion is really, really impactful. because now we can solve problems at a grand scale, and out of that research, out of that work that we do jointly, there's going to be a number of innovations that will come out, right, that will help the entire ecosystem. So it's while we're working together, the benefits will be felt not just by the two companies, but rather the entire ecosystem. So to me, it's a match made in heaven.
Yeah, we are on the great path to democratize physical AI, and we saw that generative AI had a great adoption in 2023. So what watershed moment do you foresee for physical AI? What are you excited the most going forward, Sri?
Yeah, I don't think there is one single moment for, unlike generative AI, when 2 years ago we had that moment. I think with physical AI, because this is one of those areas where it won't happen on a single day. Right? It's going to be gradual, but accelerating rapidly. And so as the sensors become more capable, as the action activities become more safe and secure and reliable, as the models become more comprehensive, we're going to see rapid expansion of where and how robotics are going to get deployed with AI brains. And that expansion is going to happen across every industry, across every geography that you can imagine. So I don't think there is a single moment per se. If there is one that has already happened, which is AI in itself, right, and the fusion of robotics. So I think that this is going to be a rapid, but rather expansion that's going to continue to happen. I don't know if you agree.
Yeah, no, you're fully right, Sri. I fully agree. I think somehow the inflection point has already been reached. Yeah, we already see an accelerated movement, and more people not asking what and why, but how and how quickly. And so I think we're already getting into that point. And I think one real issue is when we talk about learning about these models, and now the foundational models will be built, and Siemens itself will really invest heavily under the leadership of Vasi Philemon now in the development of an industrial foundational model. And these models will no longer forget. Whatever they learn, they will add to what they have learned before. And so that in and of itself lends itself to an explosive growth curve. Yeah? And that is something that we will be observing. We have to keep in mind, though, one thing. We have to be careful with the trust and the concrete real-life experience that our customers make with our first applications. Yeah? Because in physical AI, 85% right is not enough. It has to be 99.99% right, if not even 9 nines after the comma in some processes. And we have to know when we apply new tools to such processes whether we can fulfill the promise. Because trust, as we all know, is lost very quickly, but only earned the hard way. And I think we have to go the hard way, step by step, to demonstrate the capabilities that we already have and that are expanding rapidly, but be perhaps sometimes, especially in the physical AI field, careful of not over-promising. That could backfire tremendously. But if we do that, I think we are on a joint journey with our customers and big important partners like yourselves. And I think it's exciting times. We will push things forward, and we will see more autonomous factories with the higher levels of productivities, higher levels of flexibility, sustainability, resilience, that in the end will serve us all for the better. And so I think that's exciting to do.
Thank you very much, Sri and Horst, for this insightful conversation about physical AI. Today we explored how physical AI is transforming all industries, giving machines eyes to see, brain to think, and hands to act. And while showcasing how innovations from Siemens and AWS democratizing physical AI for companies of all sizes. Thank you.
Thank you. Thank you. Thank you.